Hello everyone and welcome. In this video I'm going to explain the merge sort algorithm in the most simplified way possible. In the end, I'm also going to show you a code example in C++, although you don't necessarily need to know C++. The only requirement is that you're comfortable with the basics of programming. So merge sort is a divide and conquer type of algorithm. This means we're going to split our main problem into smaller subproblems, solve those subproblems, and then merge the solutions back together to solve the original problem, hence the name merge sort. Now, suppose we have this unsorted array. We're going to successively split it until we're left with two element arrays, which we're then going to sort by direct comparison of those elements. Then all we have to do is merge these subarrays back together in a sorted manner until we reach the final sorted array. Now let's talk time complexity and use cases. I'm going to provide a comparative analysis between merge sort and two of the most well-known sorting algorithms, quicksort and insertion sort. Merge sort has a time complexity of O of n log of n in both the worst and average cases, whereas quicksort and insertion sort are on average O of n log of n and O of n respectively, and worst cases of O of n squared. Now, as for when you should use them, based on their complexities, merge sort is usually better for linked lists, while quicksort is usually better for large and really unsorted arrays. Although if it is really well optimized, it is usually faster than merge sort in most cases. Insertion sort, on the other hand, although seemingly has a worse time complexity in both average and worst cases, still has its uses, for example when you have small or somewhat already sorted arrays. Now let's actually implement the algorithm. As you could probably already tell, we're going to implement a recursive solution which is going to work by branches. So we're going to create various branches with the divide and conquer strategy and work on them in parallel. So now I'm here at VS Code and I'm actually going to explain the code for this algorithm. So I have here three functions. First, my merge function up here. This is going to actually merge the subarrays back together, and it's going to take in our original array and a few indices, which are going to be the left, the middle, and the right. And then the merge sort function is going to split our array into pieces until we can't split it anymore. And it's going to take in our array and the indices start and end. So let's actually code this merge sort function. So we're going to keep splitting the array until our start is greater than the end. So I'm going to say if the start is greater than or equal to the end, then we're done, right? So we're just going to return like this. And otherwise, I'm going to create here a variable which is going to be called mid, and this is going to be the middle index of our array. So this is going to be end minus the start divided by 2, like so. And now I need to call this merge sort function again for the left side of our array and for the right side of our array so that we can keep splitting it. So I'm going to say merge sort, and this is going to take in our array again. And now the start is going to be start, and the end is going to be the mid. And this is array, like so. So this is going to get the left side of our array. And then merge sort, but this time the array is going to be the same, and the start is actually going to be mid plus 1, and the end is going to be the end. So this is going to get the right side of our array. And in the end, I need to merge them back together. So this merge function takes in our array, it takes in a left, which is going to be our start, a middle, which is going to be our mid, and a right, which is going to be our end. Okay, so this is going to conclude the merge sort function where we're going to split the array into smaller arrays. Now let's actually code the function where we're going to merge those arrays. So first of all, I need to create the left array and the right array. So I need a left size and a right size. So I'm going to say int const, and this is going to be the left size, and this is going to be the middle minus the left, like so, plus 1. And I'm going to copy this, and this time it's going to be the right side. So instead of left, this is going to be right, and the right size is going to be our right, like so, minus the mid. Okay, now I'm actually going to create these arrays. So I'm going to say int, and this is going to be the left array. There's going to be new int, and the size is going to be left size. And then we're going to create another array, which is going to be the right array, and it's going to be equal to new int, and the size is going to be right size. Okay. Now I'm actually going to copy the data from our array, from our original array, to the left array and to the right array. So I'm going to say for int I equals 0. While I is smaller than the left size, let's increment I. And here I'm going to say that the left array at the index I is going to be our original array, and the index here is going to be left plus I, like so. And now I'm going to grab this, and I'm going to do the same thing for the right array. So instead of here being left, all of these are going to be right. And now the index actually is not going to be right. It is going to be mid plus 1 plus I, like this. Now, I'm going to create here a few variables, which are going to be the indexes of our array. So I'm going to say int left index is going to start out at 0. The right index is going to start out at 0. And the array index is going to start out at left. Okay, now I actually need to merge the temporary arrays back into the original array. So in order to do that, I'm going to create a while loop. And I'm going to say while the left index is smaller than the left size, and the right index is smaller than the right size, then I'm going to keep applying this little algorithm. So I'm going to say if the left array at the left index is smaller than or equal to the right array at the right index, then in this case, I'm going to say that the array at the array index is going to be the left array at the left index. And I need to increment the left index. So left index plus plus. And otherwise, so else, we're going to do the opposite. So I'm going to copy this. I'm going to paste it right here. And I'm going to change everywhere that says left to be right, like so. And in the end, I need to increment the array index. So array index plus plus. And this concludes this part. Now the next part is we're going to copy the remaining elements of the arrays, if there are still any, into the original array. So I'm going to start with the left array. I'm going to say while the left index is smaller than the left size. And in here, I'm going to say that the array at the array index is going to be the left array at the left index, and left index plus plus. So we need to increment left index, and we need to increment array index. And this is array, like so. And now I'm going to do the same thing for the right array. So I'm going to copy this. Oops, what did I do here? Okay, array, like this. Sorry about that. So I'm going to copy this. Now it is correct. And I'm going to paste this. And everywhere it says left, I'm going to say right. And this basically concludes our algorithm. Now the last thing I need to do is I need to delete our temporary array. So I'm going to delete the right array. And I'm going to delete the left array, like so. And we're done. Okay, so let's actually call this down here. I'm going to say merge sort, and this is going to take in our array, and then it's going to take in a start, which in the beginning is going to be 0, and then an end, which in the beginning is going to be the size of the array minus 1. So let's actually create this. I'm going to say int size is going to be the size of the array divided by the size of the array at the first index, like so. And we need a semicolon here. And now I'm actually going to print the element. So I'm going to say for int I equals 0, while I is smaller than the size I plus plus. And I'm going to see out the array at index I and a \n, like so. Okay, and we're actually done with everything. I'm going to run this code. Let's see if our array is sorted. Hopefully it is. And okay, as you can see, our array is completely sorted, so our algorithm works. So this basically concludes today's video. I hope the explanation was helpful. I hope you understood the code. Thank you so much for watching. If this was valuable, please like and subscribe to support the channel. Thank you so much, and I'll see you in the next video.